So I have a question here for us to take a look at. We want to find the equation of the normal line to this function at the point x equals 1. All right, well, we spent a lot of time talking about tangent lines, and we've done questions where we found the equation of a tangent line. But some people, you may not have heard this term normal line. Well, it's very similar to a tangent line. Okay, so they both start with a point on the graph, right? We're talking about x equals 1. This is actually the graph of our function here. So the tangent line at that point looks like this. Right now, the normal line is going to go through that same point, right? But it's going to be perpendicular to the tangent line. So hopefully at this point you're starting to see in your head how this is going to work, right? Because we know that the slopes of perpendicular lines are negative reciprocals of each other. And we know that we can use our derivative to find the slope of the tangent line. So just kind of applying that principle, once we get that number, we'll just take the negative reciprocal. Then we've got the equation of the slope of the normal line, and from there it's all downhill. You're just putting numbers into the point slope equation. Right, so let's look at the mechanics. Right, let's see how we're going to do this. So I've got our function here, and step number one is going to be we're going to find the derivative. Right, and to do that, we're going to use the quotient rule. Or remember how the quotient rule works. It's the bottom times the derivative of the top minus the top times the derivative of the bottom, all divided by the bottom square. So the two derivative parts up in the numerator, they're pretty straightforward. The derivative of x squared is just 2x, and the derivative of x squared plus 1, well, that's also 2x. Okay, so here's a formula for the derivative of our function. Now, at this point, I'm going to offend just probably whole generations of calculus professors and teachers. I am not going to simplify that expression. Because, I mean, I could, sure. It's a, excuse me, I mean, it's a messy algebra. But look, I'm trying to answer this question here. And I don't want to do a whole lot of, again, messy algebra manipulations that I don't have to do, right? All I need to know is what is f prime of 1. And I can get there pretty easily just by putting 1 even into that somewhat messy expression, because now it's just an arithmetic problem, right? And if you simplify that expression there, which is still a lot easier than simplifying that algebra would have been, you get that f prime of 1 is 1/2. That's all I needed to know. Right, so now that's the slope of the tangent line, right? But we're looking for the normal line. Well, the slope of the normal line, that's the perpendicular. So it's going to be the negative reciprocal of 1/2. That's just negative 2. All right, so now ultimately, remember what our goal is here. We want to find the equation of a line. So to do that, we need two things. We need the slope, which we've got, and we need the coordinates of a point. Well, we want the point that's on the function when x equals 1, right? So if I calculate f of 1, that's just putting 1 into that function formula, we get f of 1 is equal to 1/2. So now I have my point, right? The slope of my line is negative 2, and it goes through the point 1, 1/2. So if I take those three numbers and I put them into the point slope equation for a line, I get this thing here. And then technically, yeah, okay, that could be the answer. But we always want to simplify. When we're talking about the equation of a line, that generally means putting it into the point slope form. So I need to take this, and I need to solve it for y. And if I do that, we end up with y equals negative 2x plus 5/2. And that's it. Right? That's going to be the equation of the normal line to that function at the point where x equals 1. All right, so if you'd like to get the full context, you can click on the link here to see the corresponding lecture. And if you like this example or found it helpful, please go ahead and click on the like button down below.